ratios and proportions. It's going to be almost a little bit of algebra 1 today. All right? So, no. Oh, yeah, you can put relation. You can put this on the top. I forgot I did not give you the sheet. Ratios and proportions. Jonathan, that's not going to work. You're not going to be able to watch me with your head turned back. So we got to find you a new seat. For the notes, go sit at that table right there, Jonathan. This one right here. So you can see. Okay, that's even better. All right, so. All right, so let's talk about the definition of a ratio. A definition of a ratio is the comparison of two things. That's all it is. Comparison of two things. So, if I wanted to do the comparison of people with jackets on versus people without jackets on, jackets to no jackets in this class. Right now, I have 1, 2, and I'm not using sweatshirts. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm counting you as no right now. 9 people with jackets. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 people without jackets. So it's 9 to 16. All right? We could have done from juniors to seniors in a class. You can do male, female. It does not matter. But this is a ratio. A proportion is when you set two ratios equal to each other. Two ratios equal to each other. So, here's an example. A over B is equal to C over D. Sometimes y'all think of this as just cross multiplication. Or, if I was to tell you that there were the ratio of girls is 2 to 3, if I have 18 boys in the class, how many girls are in the class? So, if I was to say the ratio of girls to boys is 2 to 3. Okay? You with me? If there are 18 boys in the class, how many girls are there in the class? So you would have done 2 to 3 is equal to, I said 18 boys. Where would that go? Numerator or denominator? Denominator. How many girls? So this is just a straight cross multiplication. What would it be? 3x is equal to, when I multiply these two together, I'm multiplying these two and I'm multiplying these two. 36. And then let's divide by 3. So that means that there are 12 girls in that class. That's all that is. Okay? Now, there are different ways Thirty-six. All right, real quick, I just need to see something real quick. All right, perfect. You all don't have this, but I'm going to go over it. Cross product proportion in a proportion AB is equal to CD, which you already know how to do cross product. That's why you all do not have this. Okay? So, let's go ahead and let's solve these three. I'm going to solve problem number 2. And you're also going to do 1 and 3. Everybody watch me on problem number 2 before we even get started. Alright, so let's cross multiply. Here we go. When I cross multiply, I am going to get, it does not matter if you do the red circle first or the purple circle. I will do the purple, so it's 10 times x minus 3 is equal to 5 times x. Now, we're going to distribute. When you distribute, you get 10x minus 30, 5x. Now, we're going to, I bring all my variables to the left, which is what I do. So I'm going to subtract 5x both sides. When I subtract 5x, I'm going to get, 5x minus 30 equals what? 0. Why not? You're not allowed to leave school to go to play first class, but you do it. Right? Oh, okay, thank you. So, add 30 to both sides. 5x is equal to 30. 5 by 5. X is equal to 6. What? Cross multiply? No. You can go the opposite direction. It does not matter. So it would be 10x minus 5. Yes. If you brought the 10x over, it is fine. All right, ladies and gentlemen, you need to do 1 and 3. Go. This one, when you cross multiply, you should have gotten 4x is equal to 16 divided by 4. X is equal to 4. Good to go? This one, when I cross multiply, 7 times x minus 5 is equal to 2x. 7x minus 35 is equal to 2x. Subtract 2x to both sides. 5x minus 35 is equal to 0. Add 35. 5x is equal to 35 divided by 5. X is equal to 7. So far, so good? All right, now, here's the thing. There are many ways that can be equivalent to the forms of proportion. So, if I was given, I don't know why this is all over the place, if I was given A over B is equal to C over D, there's a couple of ways that you all can set these equal to each other. You could say AB is equal to CD, okay? We could have flipped them and said B over A is equal to D over C. Everybody with me? There's many ways that you can do it. The key is when I cross multiply, A and B are the two that are being multiplied together. And B and C are the two that are going to be multiplied together. If I was to write this, A plus B over B, what would I write on the other side so it matches? What would I write on the other side so it matches? C plus D over what? Over D. Is everybody with me? All right, now, with that being said, look across, and I want you to fill in this information. The problem is up here. I will write it again because it looks like it doesn't show. I want you to tell me, that's a Z, what would be the answers that go here. Go for it. No. It says, look at this. This is my original proportion. Everybody with me? It says x over 2. X over 2. What do you think I'm going to write in the second one? 10 over z. This is my original. They are changing the original, but it has to still be equivalent. So they said x over 2. I need to put the denominators together. 10 over z. Now see if you can figure out the other two. It says 10 over x. Let's look at the pattern here. It went denominator to numerator. So what do I need to do for the other one? Z, denominator, over numerator. 10z over 2. There it is. This one says x plus 10 over 10. So what do you think you're going to put here? Oh, 2 plus z over z. Does everybody see why it's 2 plus z? Let's look at this. It says x plus 10. X, numerator, plus denominator, over denominator, right? So what do I need to do for the other one? Numerator, plus denominator, over denominator. You see that? All right. Now, let's go ahead and talk about similar polygons. All right. This is the difference. What does congruent mean? Equal. What do you think similar means? Oh, kind of the same. We say it all the time. Girls do it all the time. Oh, I got that shirt. But y'all finish talking? I got that shirt, but it's in red. I got that same shirt. No, you do not have the same shirt. It's similar to that shirt. Or I have that same shirt, but mine has sequences on it. Then it's not the same shirt. It's similar to that shirt. All right? So, in similar figures, they have the same shape, but different size. All right? They're the same shape, but not necessarily the same size. In order for a polygon to be similar, the angles, corresponding angles are congruent. Are congruent, but their sides are proportional. Now, do y'all remember the congruent statement? We could put the sides equal to each other. We can't put a side equal to each other here. We have to do a proportion. Okay? So, let's go over it. This similar statement, what does a congruent statement look like?
Oh, it's squiggly and
That was the congruent statement, right? But then we can say that they are not the same. They're not equal. They're like them, but they're not equal. So therefore, we don't use the same congruent sign. We just don't put the equal sign underneath. It's just a squiggly. So let me give you an example. Triangle ABC is similar to triangle DEF. And here goes my shape right here. So, this would be ABC. That would be DEF. So, A, B, C, D, E, F. They are similar, same shape, same angles, but they're different sizes. Okay?
what does it look like now?
It doesn't matter. They're still the same shape, but different sizes. All right? That's just like, let's go back to the shirt. Alice is wearing the shirt. Lady has the same similar shirt, but hers is folded up in her closet. It's still the same shirt, similar shirt. They're not both worn. All right. Very important. You always need to match up the corresponding size, just like we did with the congruent statement. First, for two figures, the smaller two sides correspond, always. The medium two sides correspond, and then the larger two sides correspond. So you match up the small with the small, medium with the medium, and large with the large. Similar scale ratio or scale factor is the length of the length. The ratio of the length of corresponding sides. Move it up so y'all can see it. And let's go over some examples. Put it over and you go over some examples. Of course. Now, here we go. Draw a line. This is going to be for you guys. Draw a line from each angle in column A that corresponds with the angle in column B. That's all I'm going to say with what angle? G. If you look at them, they both have, angle A corresponds with angle G. Not only do they both have right angles, they also, if you look at the similarity statement, they're both the first letter for each figure. Is everybody with me? Now, B needs to go with what? H. C goes with what? I. And D goes with, C goes with I. D goes with J. All right, now, looking at the statement that we have here, let's complete the proportion. AB corresponds with GH. If you notice, they're the first two letters in both in the similarity statement. Everybody with me? BC should go with what? HI. What should go with IJ? BD. And AD, because they're the first and the last letter, should go with what? GJ. That's how you're going to set up your proportion. Okay? Now, I want you all to set it up. This time I'm not giving you a picture. What do I need to use this time in order to set this problem up? The statement. So go ahead and fill these in according to the statement. D goes with what? H. E goes with J. K goes with F. Who does not notice that Y K goes with F? You can give me a one finger up and I will see you. Anybody have? Give me a finger or something to let me know that you don't know that these. All right, let's go. Look at this. K. Look at K. What letter is it on here? 1, 2, 3, or 4? It's the third one. So it has to go with the third one on this side. 1, 2, 3. That's where we're getting F. All right? L is the last letter on the right side. So it must go with the last letter on the left figure, which is G. Now, when you look at these, DE is 1, 2. So it goes with HJ. HJ. Right? EF should go with JK. KL are the last two letters, so they should go with FG. And we're missing one. Which one are we missing? DG, which is the first and the last letter, should go with what? HL. Right. Does everybody have that? All right. Now, with you all knowing that, okay, we are going to compare angles and compare ratios. Remember, angles should be congruent, sides should be proportional. Okay? So, if you look at this, angle A and angle X, do you notice that they have the same arc, number of arcs? Is everybody with me? So that means that they are equal to each other, because they're the same. That phone better be over here. Is it over here in this thing that I keep hearing beep? Okay. Now, B, do you know it has two tick marks? And Y has two tick marks, or two arcs. So that means that they are equal. C has three marks, so does D. So that means they are equal. And D and W the same way. Now, we now need to see the ratio of the sides. Okay? If I did AB over XY, that would be 6 over 3, which gives me 2. I went and did every proportion, similar to what the proportions up here. If I had numbers on this one, and I put the numbers in their spot, that's what I'm doing here. You all notice that they all equal 2. Everybody with me? So that means that the sides are proportional because they all equal the same number. So therefore, because the corresponding sides are proportional, or you could say equal, and the angles, corresponding angles are equal, that means that the figures are similar. Okay? Now, if I wanted to extend this ratio, this is how you would extend it. AB over XY is equal to what? What will be another ratio I can put from this figure? What other one can I put? I did AB and XY. What else can I put? CB over ZW is also equal to what? BC over YZ, which is also equal to what? DA over WX. I am extending it by putting all of the ratios equal to each other. I can't solve a problem with all of them here, but at least I know which ones are equal to each other. I'm going to let you know right now, on the SOL, they are going to, like Jonathan said, they're going to put the pictures different. They look like they should correspond, but they're not. You have to look at the the similarity statement only. All right. Now, here's the question. Are they similar or are they not?
No.
Let's look. Let's start with the first one. Y'all going to do the other three on your own. First one, let's look at it. Do the angles match up? Do I have one arc, two arcs, and then three arcs on all three triangles? Yes or no? Yes. So now, we do not know which sides are corresponding to which sides. We do not have a similarity statement. But we can do small, medium, and large. Okay? So we're going to start with this triangle. I always use the smaller figure on top and the larger figure on the bottom. Here's my question to you. What is the smallest side on here? Which is what? What number? 24. Oh, I'm sorry. No, it's not. Let's look at this. Let's do it again. right here. It is QR, which is 18, right? We're going to make two lines. I'm going to put an 18 there.
18 over 8.
What is the smallest side of this triangle? In the letters. KL, which is what? Henry? 30. Is everybody with me? Did I lose anybody? Now, what is the medium side over here? QS, which is what, Henry?
3.
All right. What is the the medium side on this one? KM, which is 40. Did I lose anybody? All right. What is the largest side of the small triangle? RS, which is 36. And then the largest side on the LM, which is 60. Now, we have to see if these are proportional. This is where your calculator comes in. In your calculator, put 18 divided by 30 and tell me what you get. No, just put 18 divided by 30. You get 0.6. Put 24 divided by 30. Put 36 divided by 60. Now, they're supposed to be what? Equal, right? Are all of these ratios equal? No. So guess what? It is not similar. Did you get 0.6 for this one or 0.8? 24 over 40? Don't put in the calculator. You said 0.8. Try to get it. 24 divided by 40. Oh, 0.6. So they are all equal. So therefore, oh, gotcha. Not got enough time to finish talking. Let's wait, y'all. We got to pause for their conversation. I'm talking to you two. So, now that we know that they are similar, let's go ahead and write. Need to write a statement? No. No. Yep. Write a similarity statement. Here we go. Triangle. Someone give me one. Q what? QRS is similar to a triangle. Oh. KLM. There it is. Now, let's go back. You know how we made the mistake and we said this was 0.8. Everybody with me? If that was 0.8, then these triangles are not similar because they're all not the same decimal. Does that make sense? Now, I want you to go ahead and do number 2, number 3, and number 4. Do the rest. Go for it. All right, here we go. Ladies and gentlemen, I'm going to start with this one down here. First of all, are they similar? Yes or no?
No.
I don't know.
No.
First of all, are they the same?
No.
One is a square, one's a rectangle. Even though they have the same angle, there's no way that all their sides will be proportional. Two rectangles are similar to each other. Two squares are similar to each other. Is everybody with me? Like if you look at those pictures over here, if you look at my wall over here, my bulletin board, where it says you are, that is similar to all the ones on the right, even though one is smaller and one is bigger. Okay? That at the top where it says when you enter this classroom, that can't be similar to any of those because that's square. So this is not similar, just off the bat. Now, if you did this, you would have seen that all the tops were 6, right? And the bottoms were 4, 4, 8, 8. This cannot equal that. Is everybody with me? All right. Now, are these similar? Yes or no? Why not? Look at these angles. Y'all paying attention? These angles are different. Remember, the angles have to be congruent. So that's why, even though the sides are matched up, these are not the same angles. So not similar. Now let's go up to the top. All right? Here we go. So this is going to be, let's look at it. I'm just going to do the numbers first, and let's see what we get. This is going to be 14 over 20 is equal to 21 over 30, which is equal to 28 over 40. Is everybody with me? Now, when you reduce 14 over 20, what did y'all get? 0.7, what'd you get here? What'd you get here? So therefore, they are similar. So I could say triangle YZX is similar to triangle B what? YZX is similar to what? Look. This is one of those examples, Jonathan. Y'all see how they tried to trick you here? Let me show you why they tried to trick you here. I said YZ. It goes from 2 arcs to 3 arcs. So you have to go 2 arcs to 3 arcs, which is a Z. You can't go in the same order. No. That's why you need to pay attention. What did I just say? Henry, listen. It goes from 2 arcs, I said BC, and 2 arcs, 3 arcs. So 2 arcs, 3 arcs. Are you with me? All right, now, moving on. Jessica, this is like for me. All right, if you know how tall you are, then you can determine how tall the tree is. By similar triangles. This is what people do. They use similar triangles to figure this out. If you look at this tree casts a shadow of 10 feet. Okay? You are 6 feet tall, and you cast. Are you kidding me? You're not paying attention. What did I just say? What this? And how much? Don't look up there. No, please don't pay attention. You are 6 feet, and you cast a shadow of 2 feet. Everybody with me? If you notice, here's your triangle right here. You're trying to find out how tall this tree is. So, let's set up this proportion. Someone set up a proportion for me to figure out. I'm sorry, you don't need an X there. Set up a proportion for this. Go for it. Someone say it to me. I like that one. That's one of them. He said, my shadow over the tree shadow is equal to my height over the tree's height. Someone give me another one. 2 over 10 is equal to 6 over x. That was one I could have done. Someone give me another one. How else can I set this up? You can't do 6 over 10 because they're 2 different things. One's height and one is shadow. Huh? 10 over 2 is equal to 6 over, I'm sorry, is it 10 over 2 is equal to what? 10 over 2 is going to equal what? X over 6. Now, you can, are you done with your conversation? Please don't let me interrupt your conversation. Because if I stop, we're not graduating. So let me know. We done with conversation? Now, you could have done the comparison of the tree to the comparison of the person. You can't just switch swap. So you could have said x over 10 is equal to what? 6 over 2. Now, if you notice, when I cross multiply, I am multiplying no matter which one of these I use, I'm still multiplying the same two numbers together. Does everybody see that? Does anyone not see it? They're the same two numbers regardless. So to find the height of the tree, this is going to be 2x equals 60. Divide by 2. X is equal to 30. So the tree is 30 feet tall. That's how you find the height of a figure. Now, next class, you all are going to find the height of, I brought it in here, the height of the flagpole, the height of the light pole, and possibly the height of the building using this. This is all you're using in your body. There is no way that people find, you have to think of it this way, it's called indirect measurement. You do not find, you don't have a tape measure that measures how tall a light pole is. No one is going to stand at the top, hold it, and you stretch it all the way down and say, oh, you can't do that. If I find the height of the building, you're thinking, now all tall enough. You can't find the height of a building by stretching it from here all the way down. So what you have to do is you use what you know. You know the measurement of yourself. You know the measurement of the ground according to a position with this mirror. So you can take the indirect measurement similar to this and then find the height of it. Yes. Yeah, and I'm going to show it to you in a minute. Okay? Now, what you're going to do, real quick, let's go ahead and solve this problem. All right? Is everybody with me? And it looks like the rest of y'all are going to have to do for homework or during flex. Here's the thing. If you notice this, you do not know your small, medium, and large because they're all not here. You don't see that? Is everybody with me? You do not know if I'm going to compare the 4 with the 2 or the 4 with the 7. I don't know. But what I do have is a similarity statement. So what I need you to do is the first thing you're going to do is we are going to say what compares to what. RS goes over what side? According to my similarity statement. UV. ST goes over what side? ST goes over what? VW. And RT goes over what? What? RT. UW. Everybody needs to make sure they got that written down, including Carlos and Javier. Now that you have that, let's fill in information that I know. I'm going to draw 3 lines here. These are my 3 ratios. Some of them I'm going to have values for and some I am not. Watch this. Everybody look up here at me. Is everybody looking? No. Here we go. RT is 7. Is everybody, RT is 4. Is everybody with me? So I'm going to put a 4 for RT plus. Look up here. Don't do it yet. ST is 7. RS is 6. You look up here, UW is 2. WV is X. Everybody with me? That's the side I'm looking for. Now you can see what 2 ratios I need to set up equal to in order to solve this problem. As you see, I do not have another value here. Or they asked me, they didn't say Y. So I'm not going to, matter of fact, let's put a Y here. We're going to find them all. Now, you're going to use the scale factor that you have in order to solve them. So my first equation is going to be this one. Do y'all see that? Is everybody with me? So your first equation, you're going to write, you all have plenty of paper on this, 4 over 2, and then solve it. You're using that 4 over 2 to find x. So if I cross multiply, I get 4x is equal to 14. Divide by 4. X is equal to 3.5. Did I lose anybody on how I did that? Now, to find y, look at this. To find y, these are my two ratios I have to set up. Are you ready? I have to use this one because that's the one I have values for. That's my scale factor. And I'm going to use this one. So it would be 6 over y is equal to 4 over 2. Cross multiply, 4y is equal to 12. So y is equal to 3. There is my answer. Did I lose anybody on what I just did? All right, so we only have 10 minutes, but I'm letting you know right now. This is going to be the work when you come back.